Okay, hello. We're going to go ahead and take a look at this worksheet here, day 11 worksheet, normal distributions. You have some notes here. You can use this for the test if you want. All right, kind of the directions here, but we're going to draw this by hand, each one. But the first one is a line up for tickets to a local concert, average mean time, the wait time, 20 minutes. All right, a standard deviation of 4 minutes. So we draw our number line right in the middle, put the mean. That's 20. All right, standard deviation of 4, so up 2, down 2. This is 24, this is 28, this is 16, and this is 12. Draw your curve, just kind of do it the best you can, something like that. Draw out, start at the top, above the 20, and go outside of the 12. And just like this one, come down and go outside of the 28, something like that. It doesn't have to be perfect, but you need to have the percentages all marked in here. All right, again, I'm hoping that you guys eventually get this all down. But this is 34%, 34%. This is 13.5%. And outside here, that's 2.5. All right, everything out here is 2.5. All right, you can go 2 more standard deviations, but out here is 2.5, just like this side. This side is 2.5 right here, okay? Now what they're asking is what percent of the people in line waited for more than 28 minutes? Well, here's 28 minutes right there. So everything bigger than 28 minutes, a percentage. They want a percentage. It's 2.5. Right there, that part right there. Now, if there were 2,000 ticket buyers in line, how many of them expected to wait for less than 16? Well, here's 16. Less than 16 would be down here, everything down here. So take these two percentages and add them up. It's 2.5 plus 13.5. That equals 16%. 16%. But they're saying 2,000 ticket buyers. What's 16% of that? Well, multiply it times 0.16. So I go at 320. All right, 320 ticket buyers. All right. As every one of these, we're going to draw that top part the same. The only thing that's different is the bottom part, the number line. Every one of these, okay? So here we go. Number 2 is the math test. Right again, draw the number line. The mean is 75, that goes in the middle. Standard deviation is 5. So this goes up 1, 2, that's 80 and 85. Down 1, 2, that's 70 and 65. Come up above here to the 75 and just kind of come down like that and then out like that. Down like that and then out like that. There we go. Draw your percentages. Again, this is 34. This is 34. This is 13 and a half. This is 13 and a half. This is 2.5. Make sure you put the percent sign. It's not 2.5, it's 2.5%. All right? All right, now again, they're asking, looks like it's the same answer. What percent of students scored higher than 85? Well, here's 85. Higher than that is all this up here. What percentage is 2.5%? All right. What percent of students score between 70 and 80? Well, guys, here's 70, and here's 80. Everything in between there. So everything, all that part right there, all right? Take these two percentages and add them up. 34 plus 34, that's 68%. And of course it's 68%. That's one deviation, one standard deviation from the mean. And we know that 68% of the data lies one standard deviation from the mean. All right? And the next one's the Oreo factory. Again, start, draw the number line. Doesn't have to be perfect, just do your best. The mean is 40 grams. Standard deviation is 2. So this is 42 and 44. This is 38 and 36. All right. Up top here, draw a curve. Put your percentages in there. All right, 2.5. That's right there. And 2.5. That's that one right there. All right. If 10,000 cookies were produced, how many are within 2 grams of the mean? Well, here's the mean. 2 grams is all this right here. Again, it's one standard deviation from the mean on both sides. So 34 plus 34 is 68%. Again, that's one standard deviation from the mean, 68%. All right? But there's 10,000 cookies. They're asking how many cookies. So it's 10,000 times 0.68, 68%. All right, 6,800 cookies. Again, if cookies are rejected if they weigh more than 44, so that's here and up, or less than 36, that's here and down. All right, they can't be too big and they can't be too small. They all want their cookies to look about the same in the package. All right, so below 36 is 2.5% plus. Above 44 is another 2.5%. That's 5%. So 5% of the cookies will be rejected. Out of 10,000, how many is that? Guys, be careful. Use 0.05. It's not 0.5. That's 50%. Your answer is not 5,000. They don't reject 5,000 cookies. They reject 5%, not 50. They reject 500 cookies. All right? All right, next, guys, I'm running out of time here. I'll do this number 4. I'm hoping you can do number 5 by yourself. All right, this is cars on a highway. The mean is right here, 95. Standard deviation is 5, so this goes up to 100 and 105. And this goes down to 90 and 85. Draw your curve. Put your percentages in there. All the same. It's always the same, the percentages, because it's a normal distribution. The percentages, we know what they are. All right, what percent of cars average less than 85? That's right here, less than 85 is down there, it's 2.5%. If police stop the cars going faster than 105, that's up here. All right, that's another 2.5%. 8,000 cars. What's 2.5% of that? Guys, it's 0.025. Be careful. It's not 0.25. It's 0.025. Okay, what is that, 200 cars? As the last one, I'm going to save it for you. I'm hoping you can do it. All right, it's about the battery life. The mean is 50. The standard deviation is 6. And the manufacturer replaces all the batteries that have less than 38 hours. So figure out what percent is less than 38 hours, and then multiply that percentage times the 50,000 batteries, okay? I'm hoping that helped you. Thanks.